the concept also along with the problem. So yeah, here's the first question. This is from JAM exam 2022. The question is, you want to find rank of this matrix. A 4 cross 6 matrix is given. So what is the rank of this matrix? So can someone tell me how should I mean how can we solve this problem? One method, right? That is
Sir, this is a transformation from R6 to R4.
mhm,
So the dimension should be 6.
dimension of the domain, right? That is 6, correct? R6.
Yes. So we can take up.
Okay, first of all, let's try to see what is rank of a matrix. So one way to define rank of a matrix is number of linearly independent uh, rows in that matrix or number of linearly independent columns. Equivalently, as someone said right now, we can think of this matrix as a linear transformation from R6 to R4, and dimension of the image of T, which is same as column span of this matrix T. That is what we call as rank. So, and one way to calculate rank is to reduce this matrix by row echelon method. Or yeah, someone says that finding non-vanishing minor. That is also correct. But you have to find a minor of largest possible size that is non-zero. Uh, so here I have presented a simple solution using row reduction. If you can directly see largest size minor which is non-zero, means the determinant is non-zero, then of course, for example, here we can see that there is a 3 cross 3 identity matrix. That means the uh, rank is going to be at least 3, but it may be 4 also. So yeah, let us try row reduction. So let me not do like go through all the computation. If anyone doesn't know how row reduction is done, then you can ask. Otherwise, the idea is I have this 1. I'll first of all try to make it 0. For that, I'm doing this transformation, row 2 minus row 1. So here I have got 0. Next, I'll try to make this 0 and so on. So finally, I get this matrix where I can see that uh, there are these 4 pivot entries. And so this first 4 cross 4 block is an invertible matrix. In other words, the first 4 rows are invertible. So its rank is 4. So I hope this solution was clear. Any doubts?
No, sir.
Yeah.
No, sir, it's clear.
Okay. Let's try another problem. Similar sort. So this question is again from JAM 2022. That's why this number 18. Anyway, so we are given a system of 4 equations in 4 unknowns: x, y, z, and t. And lambda is a constant. And the question asks for different values of lambda, what is the nature of solution set of this system? Does it have a unique solution, infinitely many solutions, and blah blah blah. So yeah, what is the idea? How should we solve this? Whenever you see such a system, you just try to convert it to matrix form, just like we did previously. This is the matrix form. So the first equation was x plus z plus t equal to 4. X plus x plus y plus t equal to 4, which corresponds to this first row, x plus y plus 0z plus 1t equal to 4. So these places These columns correspond to coefficients of x, y, z, and t, and this is the constant term. And again, the idea is same. You use row reduction to simplify this. I hope this is known. So by row reduction, I get this matrix. Now, from this, what can you conclude? So I have all zeros here, and on the right hand side, I have lambda minus 1. What does this fourth row tell us? It tells us that 0x plus 0y plus 0z plus 0 t equal to lambda minus 1. Now, for this equation to be true, because the left hand side is 0, right hand side should be 0. That means what should be the value of lambda? Lambda should be 1 if we want this system to have a solution. That means if lambda is not equal to 1, then there is no solution. Let's come back to the options. So lambda equal to 2, infinitely many solutions is definitely not correct, because the moment lambda is not equal to 1, we know that there is no solution. So these two options are gone. And now we just have to check what happens if lambda is equal to 1. So if lambda is equal to 1, then we get a system with 3 equations in 4 unknowns. And we know that such a system always has, in fact,
solutions.
Infinitely many solutions. Yeah, 3 equations in 4 unknowns. By the way, it depends on the system. This statement is not true in general. For example, I can take something like x plus y plus z equal to 10 and x plus y plus z equal to 5. Now, this is a system where there are more number of variables than the number of equations, but this system has no solution. Why does it work here in this case? Because of the special form that we have. So, for example, focus on this part, this matrix. So, yeah, my point is, just because you have a system with 3 equations and 4 unknowns does not imply that the system will have infinitely many solutions. Why does it work here? Because, for example, here there is no problem with the fourth equation. We are assuming lambda equal to 1. Now you pick any value for the variable t, that will give you a value for variable z. Once you have values for z and t, it will give you value for y using this equation, the second one. And you put these 3 values to get value of x using the first equation. So it is the special form of this new system that we have got, whose solution set is equal to the solution set of the original system. The special form tells us that we will get infinitely many solutions. Okay, so for lambda equal to 1, we have infinitely many solutions, and option C is correct. So both these problems were based on row reduction of a matrix. Okay, if there is any doubt, you can ask. Otherwise, oh yeah, I think you will get at least one such question in every exam you write based on row reduction in some form or the other. For example, the first question was a direct one. You were just asked to calculate rank directly by row reduction. Here, you had to convert this to a matrix and then do the row reduction process. What's the difference? Okay, one more question from JAM, last year's JAM. So, V is given to be all polynomials over R of degree less than or equal to 6 together with the 0 polynomial. Then which one of the following is a subspace of V? Can someone tell me what what is it that I have to check if I want to check that a subset W of a vector space V is a subspace of V?
Alpha A plus, if alpha and beta belongs to V, then alpha A plus beta also belongs to V.
Okay. And one more condition.
0 belongs to V.
0 belongs to W, right? So you wanted to say W. We are checking whether W is a subspace or not, right? Yeah, so what about option 1? First option A, is it a subspace? Yes, no?
No.
No, why not?
So for zero polynomial, the half is 0, which is not irrational, which is not
Correct.
irrational.
That means this is not correct. What about the second option?
Same zero polynomial doesn't belong to.
Correct. What about the third option?
Third option will be correct.
What about fourth option? This is f prime derivative evaluated at
Same zero polynomial doesn't belong to.
again 0. So it's a very simple question. You just had to know that the 0 element from your vector space should belong to every subspace, because every subspace is again a vector space. That means A, B, D are incorrect. Option C should be correct. And let's check, no? So you have f of 1 by 2 equal to f of 1, set of all such elements. Definitely 0 belongs to this set, because f of, if f is 0, f of 1 by 2 is 0 and f of 1 is also 0. And to check the second condition, you can again do the same, because this is evaluation map, no? So if you consider two elements f and g, then alpha f plus g, we want to check if this polynomial again belongs to the suppose f and g belong to W and alpha is a scalar, then as someone said, we want to check this condition, the second condition, that alpha f plus g, whether this belongs to this set or not. When will it belong to the set? If this at 1 by 2 is equal to alpha f plus g at 1. But how is this defined at 1 by 2? This is just alpha times f of 1 by 2 plus g of 1 by 2, left hand side, and right hand side is, we are checking whether this is true or not. Right hand side is alpha times f of 1 plus g of 1. Now g of 1 by 2 is equal to g of 1 because g belongs to this set. So I can cancel this. If alpha is 0, there is nothing to prove. If alpha is non-zero, I can cancel alpha. And I know that f of 1 by 2 is equal to f of 1. So both sides are equal. In other words, we have checked that if alpha is a scalar and f and g belong to this set, then alpha f plus g also belongs to this set. That's why this option C is correct. So one thing while checking whether something is a subspace or not, a good idea is to always look for some sort of equalities. For example, just by looking at this, does not belong to Q. You can see that it is not a subspace. Whereas at these three places you have equality, so you can check. And equality is also, it's, so you should check if the condition given is of the form something equal to 0. because you know that 0 should belong to the subspace, you should look for conditions that tell you in some sense that something is equal to 0. Here you have something equal to 1. 1 is a constant. Here you have something equal to 1. So these sets are most likely not going to be subspaces. Here if you see, this condition can be rewritten as f of 1 by 2 minus f of 1 equal to 0. So this is most likely going to be a subspace. Not true in general, that whenever you see something equal to 0, it's going to be a subspace, but sort of this can be taken as a necessary condition for something to be a subspace. You may not see it here for this example, what I'm trying to say, but try to see a few more examples where you are asked to check if something is a subspace or not, and try to see if you are getting some type of equality equal to 0. Anyway, so I hope this problem is okay. Yeah.
Sir,
Yeah.
so how you discard option D?
If you consider this f to be again the 0 polynomial, then what is the derivative of 0?
0.
0, right? At 1 by 2, what is the value? 0, right?
Yes, sir.
So f prime, if f is identically 0 function, then f prime at 1 by 2 is 0, which is not equal to 1. 0 polynomial, which must belong to every subspace, does not belong to this set. So this set cannot be a subspace.
Okay, sir.
Yeah. Okay. See one more problem. This set S is given. All 5 cross 5 real matrices which satisfy this condition, that ijth entry is equal to rs entry if I plus r equal to j plus s. So this I in aij, the first one, this I is I plus r is equal to j plus s. In aij, what does this I tell us? It gives us the row index. For example, if I say A23, it gives me entry in the matrix A, which is in the second row and third column, A23. So this says that you consider this set S, all 5 cross 5 matrices, which satisfy the property that Aij is equal to Ars if I plus r equal to j plus s. The row index sum is equal to column index sum. Then whichever of the following is false. What do you think, which option will be correct? Like which option is definitely not correct? Question is, which of the following statements is false? See, one of these two options should be false, right? Because if the dimension is 5, it cannot be 11. If the dimension is 11, it cannot be 5. One of these two statements is definitely false. Why is this helpful here is because we're trying to check if which of the following statements is false. This says that you don't have to go and check option A or option D, trace and all, etc. You just have to focus on calculating the dimension. Is this okay?
Yes, sir.
Yes, sir.
Yeah. So now let us try to see what type of matrices belong to S. So here I have already, let me just write down this condition once again. I'll tell you what, yeah, so this is what I have written. What was the condition? Condition was that Aij is equal to Ars if what happens, I plus r is equal to j plus s. So you start with A11, for example. Now let's take A12. Can A12 be equal to A11? I mean, does this says that if this is true, then you have equality. So is it true for A11 and A12 that this condition is satisfied? My Aij is A11, and ARS is A12. So you can see that 1 plus 1 is not same as 1 plus 2. Yeah, but you can see that if you consider A22, then this 1 plus 2, which is 3, is same as 1 plus 2, 3. That's why these two entries are going to be the same, A11 and A22. That's why I put them in the same color. Similarly, you can see that all entries on this diagonal, AII and AJJ, they are going to be the same because this condition is satisfied. AIJ equal to ARS because I plus R is J plus S. Similarly, start with this entry. We know that this entry cannot be equal to A11 because 1 plus 2 is not same as 1 plus 1. So you try to look for entries that are equal to this. So for example, you can check that 2 plus 1 is same as 1 plus 2. So A21 should be equal to A12. So this is how you can fill this complete matrix. So that's how that's what I have done. Doesn't take much time, hardly 2 minutes. Figure out the dependence here. So you can see 1, 2, 3, 4, 5. There are 5 different colors here. That's why the dimension should be 5 because there are 5 independent entries.
Sure.
Yeah.
A21 entry and A32 entry. Row means 2 here and 3 plus 5 and column sum is 2, 3.
Right. So you know that A21 is same as A12. Is that clear? Because 2 plus 1 is same as 1 plus 2. Now you consider A12 and A32. This 1 plus 3 is same as 2 plus 2. Correct?
Yes, sir, yes.
That's why. Yeah. So correct. So this relation that you can see here is not, what can I say, not a transitive relation in the sense that this condition is satisfied directly. Okay, you can say that these two are related. You can see that these two are related, but even though these two are related, this condition is not satisfied. I don't know how to put this, but yeah, you cannot directly go from A21 to A32. You have to go through A12. There's one more hint that actually this question, option 1 gives us. It tells us because we know that option B or option C, one of them should be false. That means option A should be true. Because option A is true, what does option 1 say? Option 1 says that S is a subset of set of all symmetric matrices. The matrix should be symmetric. That's why this entry must be equal to this entry. This entry must be equal to this entry. So you don't have to check this I plus R, J plus S condition for these. You can directly put them as equal and check for the rest ones. Yeah, so here this option B is correct. Sorry, option C is false. So option C should be correct. That dimension of S is 11 is false. This option is false. Is this clear?
Sir, but like we have proved that option B is correct, we can also prove that C is correct, na?
No. See, we just found that the dimension should be 5, right? Because there are
M5 matrix. Okay.
No, not because M5. There are 5 independent entries. You can assign A11 to be anything, A21 to be anything, A31 to be anything, A41 to be anything, and A51 to be anything. All other entries will be fixed. So, for example, if you set A22 to be equal to 3, this entry will be 3, this entry will be 3, and so on. So, there are 5 independent entries. That's why the dimension of this S is equal to 5. That means dimension of S is equal to 11 is a false statement, and which is what we were asked to find. Which one is a false statement? This last the dimension equal to 11 is a false statement. Okay.
Excuse me, sir.
Okay.
Skip, sir.
Yes.
Sir, how you prove that option D is true?
So I did not. I don't have to, because I have already found one option which is correct. That is option C must be correct, and this question was a single correct type. But if you want, let us check option D. What does option D say? D says that if A is a matrix which belongs to this set, and if all entries of A are integers, then 5 divides trace of A. What is trace of A?
Sum of all the
Sum of diagonal elements, right?
Yes, sir.
Yeah. All entries of A are integers. Such a matrix is given to us. That means this A11 must be an integer. Correct? All entries
Yes,
are integers.
sir.
So suppose
Yes,
A11 is n. What is A22 then?
All diagonal entries are same.
All diagonal entries are same. So what is the trace?
Sum of all diagonal entries.
N into 5.
N into 5, right? Which is 5n. Is it divisible by 5?
Okay.
Yeah, that's why this option.
I got it.
So this option is correct, but the point is you don't have to check this, because we just found a option that is false, option C. So
Yes.
okay. Yeah, let's go to the next problem. Yeah. Again, of similar type, they are asking us to find dimension of this H, something is defined as an R vector space. So what is this H? All 4 cross 4 matrices over complex numbers M such that transpose of M is equal to conjugate of M. Transpose, I hope all of you know, the rows and columns are interchanged. Do you know what this M bar is? For example, for this matrix, can someone tell me what is M bar? This is M.
1, 3, 2, 4 minus I.
4 minus I.
4 minus I. So you pick every entry in the matrix and take its complex conjugate. Complex conjugate of A plus BI is A minus BI. Okay. But what are they asking us? They are asking us to find dimension as a R vector space. First of all, can you tell me, suppose I consider this M4C, what is its dimension as a R vector space? Okay, what is its dimension as a C vector space?
(16)
4 cross 4. That means it's 16. Every entry is independent. Every Aij can be given any complex value. Now, as a real vector space, what is its dimension?
32.
32. Why? Because, for example, if you consider this A11, so A11 is what? Sum V11 plus
A plus BI. If entry is A plus BI, then in real vectors we take A as a one element and B as a one element. So there is a 2 element.
Correct. That's why 32. This is because dimension of C as a R vector space is equal to 2. So to determine a complex number, you need two real numbers, right? So total dimension of M4C as an R vector space is 32. So here they are asking us, what is the dimension of this H? M transpose equal to M bar. So once again, let us try to find the independent entries, no? So for example, suppose you know this A12, this entry. Then which entry in this matrix is known to you? Let's say A12 is B12 plus I times C12. Can you tell me what should be A21?
B12 minus I12.
B12 minus I C12?
Yes.
Why is that?
When we take transpose,
Correct.
AI K1 is nothing but A12, and then we take complex conjugate, then imaginary part will become minus.
Right. So once you know A12, you know what this A21 should be, right?
Yes, sir.
Which is this. Similarly, if you know A13, you will know what A31 is. A14 will tell you what A41 should be. Then A23 will tell you what A32 should be. And similarly, this entry and this entry. So this tells us that if you have a 4x4 matrix, A12, A13, A14, these 6 entries are independent. Once you know what these entries are, this part you can get A21, A31, and A41. What about the diagonal entries? Condition is this: M transpose equal to M bar. So if A11 is the first entry of first row first column entry of M, what is the first row first column entry of M transpose?
Same, sir.
Same, A11. What is the first row first column entry of M conjugate? It's A11 conjugate. And we want these to be the same. So a complex number is equal to its conjugate. What does that imply?
A11 should be
A is a real number. In other words, the imaginary part is 0. Right. So each star here that you can see requires two real numbers to determine it, right? Because it's a complex number, as we said. So this entry corresponds to two free variables in some sense. Similarly, two free variables at all these entries. What about these 4 entries? We know that here each AII should be a real number. So it is determined by one real number each. So all these entries correspond to a dimension 2 subspace. All the diagonal entries correspond to dimension 1 subspace. So the total dimension is, you just add all of these, it is 16. 4 plus 6 times 2, which is 16. So as a real vector space, this set H that is given to us has dimension 16. Is this clear? Not clear? Okay. So far, the problems that we saw are based on row reduction and calculating dimension, identifying if something is a subspace or not. Let's see what is next. Yeah, this is again a simple question. M is given. So all these problems are from JAM 2022. So far, whatever I have discussed. M is equal to this matrix 2 cross 2. If M raised to 8 times this 10 is xy, what is x? What is the simplest way to do this?
Sir, we should try calculating m raised to 8.
Right, you just calculate m raised to 8 and
So finding an eigenvalue
okay, finding an eigenvalue and
find the m power 8.
right, that also can be done. Here, just because it is 2 cross 2 and you are not asked to find m raised to 100 or something, it's easier to just calculate m squared, m raised to 4 and m raised to 8. M times m is m squared times m squared is m raised to 4 and m raised to 4 times m raised to 4 is m raised to 8. So yeah, you can calculate eigenvalues and do that. It may happen that the eigenvalues are complex numbers, then you are in trouble. Because I think by using eigenvalues, you want to diagonalize it, right? You want to write it like S inverse or whatever the notation is, P inverse MP or S inverse MS. This is some diagonal matrix. Then you take 100 power or 8 power. That's what you meant, right? When you said that we can calculate eigenvalues and yes. Now, by the way, this 10 may not be an eigenvector, huh, if you are referring to that. Yeah, someone is saying by finding m raised to 4 square. Correct. Yeah, that's what I have done. Take m, calculate m squared, calculate m raised to 4, calculate m raised to 8. It takes only 3 matrix multiplications, which you can do in, let's say, 1 minute or 2 minutes. And then you are calculating m raised to 8 times 10, which is 3421. And that tells you that value of x is 34. Okay, I've written something here, but let's not worry about that. There is a pattern that you get actually here. So, okay, yeah, let me just say it. Yeah, you see this m E1 is E1 plus E1, which is 1 E1 plus 1 E1. M squared E1 is 2 E1 plus 1 E1. So this 2 is this 1 plus 1. And next this 3 is this 1 plus this 2. This 5 is 2 plus 3. And this 8 is 3 plus 5. You can see there is this Fibonacci sequence that you are getting. 1, 2, then 3, 5. 2 plus 3 is 5. Then 3 plus 5 is 8. Next one. And then 8 plus 13 is 21. And so on. So for example, if they ask you to find, let's say, m raised to 20, then it's, well, then also it's efficient to actually calculate m raised to 20 and then find. what is the value of x, but one point I want to tell you here is that if you have a matrix, for example, here if you have m raised to 8, whatever, some matrix, let's say this is your matrix, and let's say E1 is 1 0 column vector, then what is this matrix times 1 0? Suppose this is your matrix. What is this times 1 0 column vector? It is 34.
First column vector.
34, 21. Sir.
21. This is the first column. If you consider 0 1, what will you get?
Twenty-one 13.
21 13. In general, if you have an n cross n matrix A, and let's say EI is 0 0 and so on, 1 at ith place, and all other zeros, then what is A times EI? It is A times EI gives
Ith column of
ith column of A. Ith column of A. Okay. Let's see. Next problem. Okay. Something based on eigenvalues. So, okay, let us recall what is an eigenvalue. So, suppose this P is a matrix. When do you say that a lambda is an eigenvalue of P?
there is a non-zero vector x such that Px equal to lambda.
If there is a non-zero vector x such that Px equal to lambda times x. Now, if this happens, then we say that lambda is an eigenvalue of P and x is an eigenvector of P corresponding to eigenvalue lambda. Right. So this question is asking us to find some entry of P. Let's read it. So let P be a 3 cross 3 real matrix and its eigenvalues are given as 0, 1, -1 corresponding to eigenvectors v1 1 0 0, v2 1 1 0, and v3 1 0 1 respectively. Something is given about eigenvalues and eigenvectors, and we are asked to find the first row and third column entry of P. That means P13. P is equal to this matrix Pij. Then we are asked to find P13, first row, third column entry. How do you do this? Any ideas?
Sir, we can make diagonal matrix.
Yes, you can make diagonal matrix, correct. You have 3 eigenvectors. And then how do you get this 1, 3, that entry of P from that? Okay, so let me tell you. See, just now we saw something, right? How can you get ith column of any matrix A? You just take A times EI. Here you have a 3 cross 3 matrix. What are they asking us? They are asking us to find P13. That means we want an entry which is in the third column of P. And we know already how to get third column of P. What is the third column of P? It is P times E3. So far, it's okay?
Yes, sir.
No, this, yeah. Okay, third column of P. Now, what is E3? You can see that it is this V3 minus V1. V3 is 101. V1 is 100. You take V3 minus V1, you get 1 minus 10, 0 minus 00, and 1 minus 01, 001, which is E3. So what is P times E3? It is P times V3 minus V1, which is same as PV3 minus PV1. What is PV3? V3 is an eigenvector corresponding to eigenvalue minus 1. So what is PV3?
Minus 1 into V3.
Minus 1 into V3. And what is PV1? Which is 0. Eigenvalue is 0. 0 times V1. So this PV3 minus PV1 is minus of V3, minus 1 times V3, which is minus 1, 0, minus 1. This entry is P13, right? Because P times E3, the third column of P. So the first entry in that is P13. That's why this option is correct. We just calculated what is the third column of P. We calculated PE3. Is this okay?
Sir, why is third column P into E3?
If you take any n-cross n matrix A, what is A times EI? It's ith column, right? Of that
Yes.
matrix A. So here you have a 3 cross 3 matrix P. P times E3 will give you third column of P.
Yes, sir.
Yeah. So this observation that what is ith column of A? It is image of EI under the transformation determined by A. That's what helped us here. I don't know, there may be this, as somebody said, no, that you can diagonalize this and do it. Yeah, maybe that is one way, but this simple observation that, or understanding that what does an ith column of a matrix give us? It gives us A times EI. That observation helped us here. Okay. Are there any doubts on this? If no, then yeah. What have I done? Understood that only. E3 is V3 minus V1 and then calculate. Okay. This is again a simple question. Let's not spend much time on this. So V is a vector space. All degree less than or equal to 5 polynomials over R together with the 0 polynomial. And T is a linear transformation that is defined by at 1 it is 1. And there is some rule. So what does this say? It says that, for example, you take k equal to 1. This says that T of x is equal to 1. You put k equal to 1, last term is x. So this says that T of x is equal to 1. For k equal to 2, this says that T of x into x minus 1 is equal to 1. This one. And so on. T of x into x minus 1 into x minus 2 is equal to 1 and so on. And what is the question? We are asked to calculate what is t raised to 3 and t of x raised to 4 and t of x raised to 3. Can someone quickly tell me how to do this? We know the value of t at 1, at x into x minus 1, at x into x minus 1, x minus 2, at x into x minus 1, x minus 2, x minus 3, and I think one more term. T is a linear transformation. No? Linear map means linear transformation. Yes. Okay, can someone tell me what is T of x squared? Oh, okay, how did you calculate it?
So
So
T of
using
x
property of
into x
linear
minus
algebra.
1 is T of x square minus T of x square minus x, and then it is T of x square minus of T of x. T of x is 1, so you get T of x square equal to 2.
This left hand side is equal to 1. Correct. T is a linear transformation. That's why you can go from here to here. And T of x square minus 1 is equal to 1. That's why T of x squared is equal to 2. Correct. Similarly, you can calculate T of x cubed. Why? Because we have T of x into x minus 1 into x minus 2 equal to 1. This thing will give you something cubic, T of x cubed plus something. But whatever this something is, you know what T of x is, you know what T of x squared is, and you know what T of 1 is. Using that, T of x cubed can be calculated. I'll just show you the calculation that I have already done. T of 1 is 1, T of x is 1, T of x into x minus 1 is 1. So someone said just now, you can calculate T of x squared from that. Similarly, you can calculate from this what is T of x cubed. Because you know T of x squared, you know T of x, you know T of 1. Similarly, you can calculate T of x raised to 4. So T of x cubed is 5, x raised to 4 is 15. So I think this is question 39. So more than one options may be correct. So I think this and this are correct. 5 and 15. Yeah. Let's go to the next problem. Let P be a 3 cross 3 matrix, real. Question is, which one of the following maps from M3R to M3R are linear? When do you say that a map T from V to V is linear?
Given image is linear.
Yeah, preserve linearity means what?
So T of alpha x plus beta y equal to alpha time tx plus beta time ty.
What is alpha? What is beta?
So scalars from
Scalars.
field.
Correct. And what are x and y?
So vectors from vector space V.
So let's say we are over real vector space. So given any alpha, beta in R, and given any x and y in V, what should be true? P of alpha x plus beta y equal to this. Okay. Now, question is very simple. They are asking us to check which one of these are linear transformations. So, is the first one a linear transformation? Definitely, if you take any m, then so P is a fixed matrix. So m, okay, let me write it this, P of m equal to P times m. This is definitely a linear transformation, right? Because here if you write instead of m some alpha times m1 plus beta times m2, if you pre-multiply by P, alpha and beta are going to come out and you will get alpha times pm1 plus beta times pm2, which is alpha times t of m1 plus beta times t of m2. First of all, is it clear that this is a linear transformation, t of m defined as p times m?
So the P and M both are matrices.
Both are matrices, yes. This m is a matrix. Yeah, from m3r to m3r. So is it clear that t of m, if I define it to be p times m, then it's a linear transformation from m3r to m3r?
Yes.
Yeah. Similarly, this t of m defined as m times p is again a linear transformation, because now you are just post multiplying by p. Whatever you were doing here, you can post multiply by p, and still alpha and beta will come out. You will get alpha times m1p plus beta times m2. So alpha times tm plus beta times tm plus tm1 plus beta times tm2. So both these t of m equal to pm and equal to mp are linear transformation. That's why their difference is a linear transformation. When you go to option number 2, so okay, once again, this P matrix can be replaced by any other matrix, right? For example, I can replace it with P squared also, which tells me that because P squared is again a matrix, and pre-multiplying by a fixed matrix gives me a linear transformation. Similarly, post-multiplying by a fixed matrix gives me a linear transformation. That's what this thing told us. This P can be replaced by any matrix which is fixed. Fixed is important. In all these A, B, C, D options, what is the variable? This M is a variable. We are putting different values of M. M comes from the domain M3R. So you can see that here, this part will define a linear transformation. Similarly, here you can see that post multiplying by a fixed matrix P squared, pre-multiplying by a fixed matrix P squared, they define linear transformation. Their sum of two linear transformations is again a linear transformation. So C is also correct. Option A and C are definitely linear transformations. What happens in option B is that you have this m squared. You have something like square of a variable. Similarly, here you have this m squared. So it is most likely that these two are not going to be linear transformations. For example, if you consider t of x equal to x squared, is this a linear transformation?
No, sir.
No,
Yeah.
sir.
Because t of x plus y need not be equal to t of x plus t of y. Yeah. This need not be true because left hand side is x squared plus y squared. So it is looks like these two should not be linear transformations. And how do you check this? So if you want to say that these two need not be linear transformations, you should produce an example where this does not define a linear transformation. The simplest thing to do is take this P to be the identity matrix. Then what does this T2 become? T2 of M is equal to P's identity now, M squared minus M. And this you can check that is not a linear transformation by taking a specific value of x and y, so specific values of m. For example, I think 3 cross 3, no? So this should work. You take m equal to this, diagonal 2, 2, 2. Then calculate T2 of m plus m and T2 of m plus T2 of m. They are going to be different. I believe so. You take 3. This should definitely work. So just check this out. I believe there is a simple argument. Maybe you can, instead of identity, you can take this matrix, which will even reduce the calculations, and using this example only, you will be able to construct. But the idea is this. You're trying to define a linear transformation. That means whatever variables appear in your equations, their power should be 1. Here, variable is m. You have second power. That's why B and D do not define linear transformations. A and C will define linear transformation. At least is the idea clear?
Sir, can we say that if m square is not linear transformation, then definitely m square minus m will not be a linear transformation?
Correct, because we already know that. That's what, no, we saw that this part is a linear transform. Which option was that? Yeah, this part is a linear transformation. So unless this part is a linear transformation, the sum is not going to be linear transformation.
Because P is fixed.
Because P is fixed. For every fixed matrix P, T of m defined as P times m defines a linear transformation, or other way also, post multiplying also. This also defines a linear.
Okay. Okay, you can see some questions from TIFR. I think in the last session, Gia already discussed this, but let's see. So far, I think all the questions were from previous year, JAM 2022, and you can see they are not very difficult. Okay, let's see this. T from Rx to Rx is given by T of f equal to f prime, derivative of f. And consider the following statements. T is nilpotent, and second is the only eigenvalue of T is 0. And which one of the following sentences is true? We are just trying to check whether statement 1 is true or not, and statement 2 is true or not. What do you think about statement 1? What is a nilpotent operator? When do you say that some T is a nilpotent linear transformation? P to the power n is 0. Then we said it is a nilpotent.
What is n?
Index
of nilpotent matrix.
Right, so a fixed natural number, that is very important. So you say that T is nilpotent.
Yes, sir.
If there is a natural number n fixed, such that what happens? You take any f, T raised to n times f should be 0. Any f in the domain. In other words, T raised to n, this function is 0. So 0 linear transformation. Okay, now tell me, is the first option correct? Is this T derivative? Yeah. So why is it correct? Okay, why is it not correct?
If we fix some n, then we can take x power n polynomial. Its n derivative will be just n factorial. This is not 0.
Right. So this T will be nilpotent, that we have derivative. It will be nilpotent if what happens? There is an n fixed natural number such that when you consider T raised to n, that applied on every f should be 0. And here, as someone said, suppose there is a natural number n such that t raised to n is 0. What does that mean? T raised to n applied to any polynomial f should be 0. What is t raised to n? Taking derivative n times. But no matter which n you choose, for that n, there is always a polynomial x raised to n such that nth derivative of x raised to n is factorial n, which is non-zero. That's why no such n exists for which t raised to n f is 0. So given any n, you have that t raised to n is non-zero, because you can always find an f such that t raised to n times that f is non-zero. That's why t is nilpotent is not correct. Is this point clear?
Yes, sir.
Yeah, but what is true is that no matter which polynomial you take, let's say you take f of x equal to some a n x raised to n plus a n minus 1 x raised to n minus 1 plus a0, there is always a power of t. For example, if this has degree n and t raised to n plus 1 applied on f of x, this is 0. This is true. So given any polynomial, there is a power of t such that t raised to that power applied to that polynomial is 0. But t is not nilpotent. Being nilpotent, and so this is what I think people call as locally nilpotent. Yeah, let's not go into what that is, but yeah, every element is killed by some power of t, but there is no uniform fixed power of t which kills all the elements. So first statement is not correct. What about the second statement? The only eigenvalue of t is 0.
True, sir.
True. Why?
Like if we take some this eigenvalue lambda, then I'll get one polynomial, say of degree n, so that t of that polynomial p equal to some lambda p. Then we can take t power n plus 1. After that, it will become automatically 0. So lambda power n plus 1 will be 0. So that will imply lambda 0.
Very good. Correct. So we will try to show that 0 is the only eigenvalue. For that, let us start with an eigenvalue lambda. So suppose lambda is an eigenvalue. What does that mean? That means that there is a non-zero vector f, a non-zero polynomial f, such that tf equal to lambda times f. Now this f has some degree. Let's say degree is n. But if f has degree n, we know that t raised to n plus 1, just now here we saw, if f has degree n, then t raised to n plus 1 of f is 0. But what should be, if lambda is an eigenvalue, what is t squared f? Is t of f. T of f is lambda f, is same as lambda times t of f, which is same as lambda squared f. T of f is lambda f, and so on. So if lambda is an eigenvalue of t with respect to eigenvector f, then we know that t raised to n plus 1 of f should be lambda raised to n plus 1. So we have t raised to n plus 1 of f equal to lambda raised to n plus 1 of f. On the other hand, we have that it is 0. So this is 0. But f is non-zero. So when is this equality possible? Only if lambda is equal to 0. So yeah, this proves that lambda should be 0 if lambda is an eigenvalue. So whatever Vishwajit, right? Whatever Vishwajit told us is correct.
So the only eigenvalue of t is 0.
Sir, why we are doing the linear maps as polynomial only?
What?
Sir, why we are taking the linear map as polynomial only?
No, I don't understand. Okay, you are saying so far the problems that we have seen in that only polynomials are being taken, or what?
Yes, sir.
I don't know. I did not set the question paper. Here you have some matrix, no? Here you don't have polynomial. But okay, that tells you that you should prepare some questions from this polynomial ring and all. Okay. Let's do some interesting problem. Don't have much time. Let's do this one. So we have a matrix A, not A, a subset A of R2 such that any continuous function from A to R is constant. And it is asked that to check whether this A is a singleton set or not. It's a true or false question. So I took this in linear algebra because what happened is, I think this question is from TIFR 2022, last year's TIFR, and I was looking for linear algebra question, and I saw this question, and you can do this using linear algebra. So I thought, okay, let's take this question also. So I'll repeat the question and I'll tell you a solution using linear algebra. Question is this: you are given a non-empty subset of R2, and what property does this subset satisfy? It satisfies that you take any continuous function from this set to R, that function is constant. The question is it true that A must be a singleton set? So how do you do this using linear algebra? So the thing is, these linear transformations are continuous functions. You can take this as a statement if you don't know this. Linear transformations are continuous functions. So I'll try to disprove this. I'll try to prove this, that A must be a singleton set. That is my claim. So to show that A is a singleton set, what do I have to do? I'll prove this by contradiction. Suppose A contains more than two elements. Let's say X and Y are two distinct elements of A. Then, because linear transformations are continuous functions, it is sufficient to find a linear transformation T such that this T takes two different values at X and Y. So that T of X is not same as T of Y. And you have a linear transformation T, a function T from A to R, which is continuous but not constant because it takes two different values at two different points. That means if the set is not singleton, there is a problem. That's why it must be singleton. Is the idea clear? So assuming that A contains more than one point, I will try to construct a linear transformation such that at X and Y are two distinct points of A, T of X is not same as T of Y. Is the idea clear?
No, sir. Please repeat it.
Okay, so we want to prove that A is a singleton set if A satisfies this condition. Okay.
Yes, sir.
So I will prove this by contradiction. Suppose I will assume that A is not a singleton set. Because A is non-empty, A must contain at least two elements if it is not singleton.
Yes, sir.
So let's say X and Y are two distinct elements of A. Now, if I can produce a linear transformation F such that f of x is not same as f of y, then I have a function such that it is not constant, right? F of x is not same as f of y.
Yes, sir.
If this f is a linear transformation, it is continuous also. That is the statement I told. That every linear transformation is a continuous function. So this is what I will try to do. That assuming that A contains two distinct points, at least two distinct points x and y, I'll try to find an f such that fx is not same as fy. What is the idea? Here is a picture. Suppose that you have this to be x and this to be y. If it happens that they lie on the same line as origin, that means if the line passing through x and y passes through origin also, that is first case, and second case is a line passing through x and y does not pass through origin. In the second case, x and y will form a, I can assume that x is non-zero, x and y will form a basis of R2, and you can define a linear transformation f by defining f of x to be whatever you want, let's say 1, and f of y to be whatever else you want, 2. So in this case, I have a linear transformation f which at x and y takes two different values. And in the first case, you have a linear transform, you take this x as one basis element and take something else as other basis element, define f of x equal to 1 at x, then at y the value should be different from 1, because if x and y lie on the same line passing through origin, y is some lambda times x, where lambda is not equal to 1 because x and y are not the same. In that case, f of y should be equal to lambda times f of x, which is equal to lambda, where lambda is not equal to 1. At x the value is 1, at y the value is lambda, which is different from 1. Other basis vector you can define anything. Well, in any case, this problem was just to show that just because you see something continuous blah 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 does not mean that there is only one way to do it using real analysis and some properties of continuous function. You can do it using something else also. And by the way, this is not, there are very simple solutions for this question than whatever I presented just now. Try to think about it, you will get it. I got it after 4 or 5 days that there is a very simple solution of this problem. This is, anyway, think about it. Yeah, but the point is, this can be done using linear algebra, using some concepts like basis and all. Anyway, let me do, yeah, this problem. So again, true or false question. There is an infinite subset S of R. Yes. You're not audible. Okay, let's do this. I'm still audible, right?
Yes, sir.
Hello? Yeah. Okay, so let's do this problem. There exists an infinite subset S of R3.
How did you find T of x and T of y?
I did not find. What I did is I defined it in such a way that I definitely know that T of x and T of y are going to be different. Did you understand the second case, this one? Okay, maybe we'll discuss this afterwards. this is unnecessarily complicating things. I am telling you. There is a very simple solution, but yeah, this was the first solution that I came up with. That's why I thought I'll just present it. Because in linear algebra there are other questions. For example, just now we saw this T of f equal to f prime. This is a derivative operator, but it's a linear transformation, right? Because you know that T of f plus g, derivative of f plus g is derivative of f plus derivative of g, which is T of f plus T of g. You can put an alpha if you want here. So this says that the derivative operator is a linear transformation. So maybe in some questions from differential equations, homogeneous differential equations, you can solve using linear algebra, because homogeneous differential operator, let's say this y double prime plus y prime plus y equal to 0, something like this. This is a linear transformation, right? What is the linear transformation? Taking second derivative plus taking first derivative plus the constant identity applied on y. Now you know that identity is a linear transformation, derivative is a linear transformation. Just now we saw this is square of the derivative. That is also a linear transformation. So this equation, which is a differential equation, is actually what? Some linear operator applied on y equal to 0. And the solution of this differential equation is precisely what? Kernel of this linear transformation. All such y such that this linear operator t applied on y is 0. The finding solution of, for example, this differential equation is same as finding kernel of this linear transformation, where you have domain to be some space, codomain to be some space, vector space, which is a space of all functions. So that is the point. If you just okay, I could not find any problem based on this, but the point is, if you see homogeneous differential equation, its solution set can be thought of as a kernel of some linear transformation. So maybe this will be useful somewhere. Just like we had that observation, no? What is ith column of a matrix? It is that matrix times ei. So it's good to have such observation, may be helpful somewhere. Just like here in this question, the complicated solution that I explained, the question was something about continuous function and all. But because you knew this property, because I knew this property that linear transformations are continuous, I thought, okay, we can apply this. So what are the things that I applied here? First is linear transformation is a continuous map, and every linear transformation is determined by its action on basis elements. So x and y were basis elements here, and x and z were basis elements here. Okay. Let's come back to this question now. There is an infinite subset S of R3 such that you take any three vectors from that set, they are linearly independent. True or false? Any idea? See, one thing we know, you take any four vectors in R3, they are going to be linearly dependent. What does this statement say? This says that does there exist an infinite subset S of R3 such that you take any three vectors from it, they are linearly independent. Any idea?
So this statement is false, right?
See, oh, this thing, let's say you have some infinite subset like this. We are not going to consider more than 3 vectors at a time. We will pick any 3 vectors. Let's say I pick v2, v100, and v507. These should be linearly independent. Just like that, if I take any vn1, vn2, vn3, this 3 element set should be linearly independent. Does there exist such a set? Is the question. So the earlier thing, no, that is not helpful here. That you take any 4 vectors, they are linearly dependent, because at a time we are considering only 3 vectors. So just because this does not form a linearly independent set, this does not really give us much information. You have a proof to conclude that it need not be true, the statement? Okay. So yeah, so this statement is true, and here is the idea. You consider this set as 1 n squared, where n is in natural number. What is this set? 1, 1, 1, 1, 2, 4, 1, 3, 9, 1, 4, 16, and so on. Now you take any 3 elements from here, 1 n1 n1 squared, 1 n2 n2 squared, 1 n3 n3 squared. If I put these 3 into a matrix, these 3 vectors, and if I form a 3 cross 3 matrix, then what is the determinant of this matrix? This van der Waals matrix, right? You know this, right? This special matrix, its determinant is equal to this. Yes, no?
No, sir. Can you explain that?
So, yeah. So this type of matrix is called as van der Waals matrix. In general, the matrix has this form. There are a bunch of ones, let's say n ones in n cross n matrix, and here you can have any values x1, x2, x3, xn. The next column, next row, you fill as x1 squared, x2 squared, x3 squared, and so on, xn squared, and so on. Next row will be x1 cubed, and so on. Finally, x1 raised to n minus 1, x2 raised to n minus 1, x3 raised to n minus 1, and so on, xn raised to n minus 1. If you consider this matrix, then its determinant is given by, this is A. I think this matrix is what is called as van der Waals matrix. And determinant of this matrix A is given by product of xj minus xi, where j is greater than I. For example, if we have only this 3 cross 3 matrix, only this much, then what is its determinant? Xj minus xi, this product, where j is greater than I. So I will have x2 minus x1, I will have x3 minus x2, and x3 minus x1, product of these three. Here it will be, for this n cross n matrix, it will be this formula. Is this matrix clear what this matrix is and how to calculate? What is the formula for its determinant?
Yes. In the chat, I'm just typing this name for your reference so that you can, if you don't know, you can search it after. Okay, so this special matrix has this particular formula for determinant. So what I did is, I took this set 1n n squared where n is in n. Now you take any three distinct elements from this. Think of it as a column vector. So this 1n n squared. So first column is 1 n1 n1 squared, 1 n2 n2 squared. The second column, and third column is this. You take any three vectors. The matrix that they form is invertible. Why? Because what is the determinant of this matrix? Just now we saw x2 minus x1, x3 minus x1, and x3 minus x2, the product. And that product is non-zero. Why? Because n1, n2, n3 are distinct. We are taking three distinct vectors from this set S, and I can see that they form a basis, right? They form a linearly independent set. So from this set S, if I pick any three vectors, they are going to form a linearly independent set. That's why such a set exists. There is an infinite subset of R3. Why infinite? For every n, I have one element here. So such a set exists. Is this clear?
Yes.
So,
Yeah.
so can you explain the last part once more?
Yeah. So did you understand how this matrix is constructed?
Yes, sir.
And how to calculate its determinant?
Yes, sir.
Yeah. You understand what is how is determinant of this matrix equal to this? N2
Yes, sir,
minus
that
n.
formula, right?
Formula, correct. Now, the question asked us whether there exists a subset S of R3, infinite subset, such that you take any three vectors from that, that set of those three vectors should be linearly independent. Now, here this is my set S, 1 n n squared, n is in natural number. The set is clear?
Yes, sir.
Is it clear that it's a subset of R3? Three tuples, right?
Yes.
Yeah. Now, if
Yes,
I
sir.
have, let's say, if I have three column vectors, let's say x1, or let's say a1, a2, a3, column vectors, three. So let's say a1 is a11, a21, a31, and so on, a2. So when is this set linearly independent? If I form a matrix using these, then that matrix should be invertible, right? Yeah, maybe this is the property that was. So if you are in Rn, and if you have n column vectors, C1, C2, and so on, Cn, then you consider n cross n matrix given by the C1 to Cn. So C1 is a column vector, it's the first column, C2 second column, and so on, Cn last column. If this matrix is invertible, then the vector C1 to Cn form a basis of Rn. This is the property that I am using. For example, 1 0 0 0 1 0 0 0 1. Is this matrix invertible? Identity, right?
Yes, sir.
What are its column? E1, E2, E3, right? They form a linearly independent set. Why? Because this matrix is invertible. Why is this matrix invertible? Its determinant is
Not equal to 0.
not equal to 0. That is one way to check. Here, the elements, the vectors that I am considering are of this form from S. So this 1 n1 n1 squared. Does this belong to S? For some, if n1 is a natural number, yes, right? So if I pick any three distinct elements from S, 1 n1 n1 squared. So this 1 n1 n1 squared, this 3 tuple, I can think of it as a column vector that I'm putting as first column for n equal to n1. This is second column, third column. Determinant of this matrix is non-zero. That's why these 3 columns form a basis of R3. In particular, they are linearly independent. So no matter which 3 distinct elements from S you pick, they are linearly independent is what we have proved. And this set is infinite. So that there exists an infinite set blah 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 with this property is true. Okay?
Yes, I understand.
Yeah. You can construct some other set also maybe, but I don't know. I thought of this solution because this van der Waals is the first thing that came to my mind. Okay. Yeah, let's do I think one more problem and then we can stop. Yeah. So a real 2 cross 2 matrix M such that M squared is equal to this -1 and -1 minus epsilon. This diagonal matrix. Such a matrix M, the options are exists for all epsilon greater than 0, does not exist for any epsilon greater than 0, exists for some epsilon greater than 0, and none of the above is true. What do you think? Any ideas?
Sir, B option.
Oh, does not exist. Okay. Yeah. What is the argument? Why does it not exist?
Sir, it is a diagonal matrix, and so M should also be diagonal matrix. And when we will square, then its diagonal entries should be positive. But here these are negative.
Okay, but if I take this matrix, this is non-diagonal, right? But its square is the identity matrix, which is diagonal. So in general, it is not true that if square of a matrix is a diagonal matrix, then the original matrix should be diagonal, right? Okay, but your answer was correct. Let me show how.
Sir,
Mm-hmm.
so eigenvalue of M should be minus I and minus I.
Eigenvalue of M should be minus. No, why is that true?
Because if eigenvalue of M is lambda, then eigenvalue of M square should be lambda square.
Correct. Yeah. So I should be I or minus I should be one of the eigenvalues, right? Because here we know that for n squared -1 is an eigenvalue. Okay, so I will be again using the same idea that you said. Let's see. Suppose λ1 and λ2 be eigenvalues of M. Then we know that eigenvalues of M squared are -1 and -1 minus lambda. So if λ1 and λ2 are eigenvalues, lambda 1 squared should be -1 and lambda 2 squared should be -1 minus epsilon. In particular, these are negative numbers, right? That means lambda 1, lambda 2 should not be real numbers. They're complex numbers, but not real numbers. So, yeah, and how do you calculate calculate eigenvalues? For example, here you have a 2 cross 2 matrix M. Its characteristic polynomial is going to be something like x squared minus ax plus b. You calculate its roots. Its roots give you the eigenvalues. What are the roots here? Lambda 1 and lambda 2. But we know that they are not real numbers. If the roots are not real and if the coefficients, M is a real matrix, so these coefficients are real numbers, that means lambda 1 and lambda 2 should be complex conjugates. So that means lambda 1 is same as lambda 2 bar. In particular, modulus of a complex number and its conjugate, we know that they are the same. So lambda 1 and lambda 2 have the same modulus. In particular, mod of lambda 1 squared is same as mod of lambda 2 squared. But what should be mod of lambda 1 squared? Mod of lambda 1 squared should be equal to 1 because lambda 1 squared should be -1. Lambda 2 squared is -1 minus epsilon, so its modulus should be -1 minus epsilon squared, which is 1 plus epsilon squared. But 1 is not same as 1 plus epsilon squared for any epsilon greater than 0. So we get a contradiction that tells us that such a matrix M should not exist for any epsilon greater than 0. Is this clear? By calculating I first of all concluded that the eigenvalues should not be real numbers. That means they must be complex conjugates. Complex conjugates have same modulus. So, in particular, mod of lambda 1 squared and mod of lambda 2 squared should be same, but they should be 1 and 1 plus epsilon squared, which are not same. So that tells us that such a matrix M should not exist for any epsilon greater than 0.
Sir, how did you conclude that these should be complex conjugates?
Yeah, because if you have a polynomial with real coefficients, it's a quadratic polynomial with real coefficients, then if a plus ib is its root, then a minus ib should also be a root, right?
Yes, sir.
Yeah. And here a plus ib is not same as a because lambda 1 here is not a real number. That means a plus ib and a minus ib are two distinct roots. But a quadratic polynomial can have at most two roots, right? Distinct. That means lambda 2 should be equal to conjugate of lambda 1, a minus lambda 1, a minus ib. Yeah, let's stop here.
Yeah, Onkar, the problems you have discussed are really good, and especially you have given some linear algebra ways to solve some analytical problems, which seems to be addressed with analytical tools, real analysis tools. That sounds to be really interesting. So I'm sure that our participants have really benefited out of it. Now, dear participants, let us now we have an interactive session, so you can ask your queries or you can share your comments regarding the lecture. Please introduce yourself before speaking. Yes.
I'm Gayatri.
Yes, Gayatri.
I have done my graduation from Miranda House College, Delhi. Thank you for taking a wonderful class. It was really useful and your explanation was very clear and it's a great step for 2023. And your academic journey is really inspiring for each one of us. Thank you, Vinod sir, for finding this kind of amazing mentors for us all the time. Thank you, sir.
Hello, sir. My name's Alina. I am currently third year BSc student of Marthama College, Kerala. Thank you, sir, for such a wonderful class. Your explanations were very detailed and you have discussed many new questions. Thank you, sir. Thank you, Vinod, sir, for conducting such a class.
Okay, Alina. Others?
Sir,
Yes.
I'm
Yeah.
a third year student. Kerala. It's really helpful to us, and you play.
Yes. Yes, thank you, Arya.
Good evening, sir. My name is Aishwarya Raharwal. I'm from Maharashtra. I'm graduate from Institute of Science. I want to ask a question that what's your interview experience and what is the little thing which you observe that we have to be remind when we go for an interview?
Yeah, so generally, so what type of interview are you talking about? PhD interview?
PhD interview.
Yeah, so for PhD interview, you should prepare at least 2 subjects well. Most of the places, interviewers ask you 2 preferences, like 2 favorite subjects, and they will ask questions from that. So try to prepare 2 subjects well, and you can even say group theory. You don't have to say, for example, differential topology is my favorite subject. Whatever you say, prepare it well and prepare 2 subjects. And one important thing during interviews is that even though you don't get the answer, you should convey to the interviewers your thinking, what you are thinking about the problem that they have given you. So it may happen that you are missing some small detail and they may be able to help you with that. They will just give you some hints and they will be able to solve the problem. So it's better not to just stay silent and think on its own and then say, okay, I'm not getting the solution. That's one thing you can keep in mind.
Okay, sir. Okay,
Yeah.
thank you, sir. And your session was so good, and it is so informative for us. You give us very detailed explanation of each and every question. So thank you so much, sir, and thank you, Vinod, sir, to arrange such kind of session for us. Thank you so much.
Thank you, Aishwarya. Others?
Hello, sir.
Yes. Yes, Zahra.
Hello, sir. I'm Zahra Rumaisa from TMG College. And thank you, sir, for this wonderful section.